Here we begin to explore looking at how to solve equations that contain absolute values. So to get us started, let's begin by recalling that the absolute value of a number, say a, is its distance from 0 on a number line. So we're going to now use the definition for the absolute value of a number to help us solve absolute value equations such as the following. So here we're asked to solve for x, and we have the absolute value of x is equal to positive 3. So let's start by thinking about how we can apply this definition to this equation. So from the definition of the absolute value of a number, we can conclude that the absolute value of x being equal to 3 is asking us to find the x values that are exactly 3 units away from 0 on the x-axis. So looking over here at our x-axis, here is our origin. So we know that positive 3 is exactly 3 units away from 0 on this x-axis. But we also know that negative 3 is a distance of 1, 2, 3 units away, again from 0 on the x-axis. So we have two solutions here, and we can make the following conclusion about the solution set for x. So the solution set for the equation, the absolute value of x being equal to 3, is equal to, or we have two distinct solutions. X can be equal to positive 3, or, as we saw on the graph, x can be equal to negative 3. So now that we've begun to establish some intuition as to how to solve these types of absolute value equations, let's go ahead and look at the more formal definition for where this is coming from. Now, given a non-negative real number k, a standard absolute value equation, such as the absolute value of x being equal to this non-negative real number k, an absolute value equation of this form can be solved directly from using the definition of the absolute value function. So let's recall that definition first. So recall that the definition for the absolute value function is a piecewise function. So we know that the absolute value of x is defined as positive x if we are considering non-negative x values in its domain. And the absolute value of x is going to be equal to minus x if we're considering negative values in the domain. Now, applying this definition to our absolute value equation, we have the following. So we can say that the absolute value of x being equal to our positive non-negative constant k, that this is equivalent to the two distinct cases. So case 1 is where x is equal to positive k, and case 2 is where negative x is equal to positive k. Now, of course, we'll keep in mind that the goal here is to solve for x. So while case 1 is all set, x is equal to positive k, with case number 2, we want to divide both sides by negative 1 here to isolate that x, leaving us with x is equal to minus k. So we can see our solution set for this absolute value equation. So now that we have developed some intuition and seen where the formal definition is coming from, let's go ahead and establish some strategy for solving these types of equations. So before we can set up the strategy for solving absolute value equations, we need to review a few properties of our absolute value equations. So to get us started, let's begin by letting k be a positive real number this time. So k is an element of the real numbers such that k is strictly greater than 0. So we have the following. So as we just saw, the absolute value of k is equivalent to the solution set, x is equal to positive k, or x is equal to negative k. Now the absolute value of x being equal to 0 is equivalent to just one x value. X is equal to 0. Our third property, now property 3 says the absolute value of x equals negative k is equivalent to nothing. Right? We know that absolute values are non-negative, so the absolute value of x can never be equal to a negative value. And last but not least, so the absolute value of x being equal to the absolute value of w is equivalent to two distinct cases. X can be equal to positive w, or x can be equal to negative w. So now that we have these four strategies or four ways to rewrite an absolute value equation, we're ready to set up the strategy to solve. So step 1 for solving an absolute value equation is to isolate the absolute value. And again, just like with radical equations, keep in mind that if you have two absolute values in your equation, simply choose one of those absolute values and isolate that one. Step 2. So step 2, we can now find the solution set by rewriting our absolute value equation in any one of these four forms. So now that we have our four properties of absolute value equations, as well as some strategy to help us solve, let's go ahead and put this to the test with some examples.